Hi there, welcome to this video on Hibernate interview questions. You can find the Hibernate link on our website as part of the frameworks tab, Hibernate, and you can look at all the questions which are really there. Let's go into the different questions which we'll discuss as part of this set of videos. First thing is why Hibernate. We'll start off with JPA, what is Java Persistence API. How is it related to Hibernate and why you should use Hibernate? We'll look at a basic architecture of Hibernate, and we'll look at things like pagination, schema generation. How do you map an entity? How do you create identifiers, and how do you really map inheritance hierarchy with Hibernate? So those are the different things that we would look at with respect to Hibernate and JPA. So let's get started. So we'll start off with JPA. What is JPA and how is Hibernate really related to JPA? So when we talk in terms of Java, we talk in terms of objects. We talk in terms of domain models. And when we talk about databases, we talk in terms of relational tables. So how do we really map a Java object to a database table? Earlier, we used to do a lot of queries. So we used to write queries to get the data from the database, and we write kind of a result mappers, row mappers, and a lot of stuff to map it to the Java objects. This was a very tiresome, cumbersome project and process, and also it was very error prone because you kind of write a lot of boilerplate code to do the mapping, and that's where JPA. That's where Hibernate came in. Hibernate said, come on, I'll be able to help you map easily the Java objects to your database. And once Hibernate became popular, JE came up with the specification called JPA. So what Java JPA was made part of Java Persistence API, was made part of the Java EE specification, and it kind of defines how a particular object can be mapped to the database. So it defines, JPA becomes kind of the API of how you can map a particular object with something in the database. And later Hibernate supported JPA. Hibernate started implementing whatever interface was defined by the JPA. So now Hibernate is really a first-class implementation of the JPA. So JPA is basically a specification of how do you map something, and Hibernate really implements that mapping. So JPA is the interface, and Hibernate is really the implementation of that particular interface. Probably that's the best way really to look at it. JPA is actually a specification, and Hibernate is an implementation of that particular specification. The great thing about using JPA is, let's say tomorrow, 2 years down the line, you see that Hibernate, there is nobody maintaining Hibernate. Hibernate, let's say, is fallen out of having good support, and you want to switch to another framework. If we are using JPA, then it's possible. If any other framework also implements the interface which is defined, the specification which is defined by JPA, we can easily switch it. It would just be the matter of switching a Hibernate jar with that particular jar, at least theoretically. So this is the benefit that JPA offers, and we in this particular video, in this particular interview questions section, we will look at directly the Hibernate things. Most of these things which we use in this particular video are JPA compliant. So the annotations might be Hibernate. Most probably they are JPA annotations. So let's get started. As we discussed earlier, what is Hibernate? It's basically an ORM framework. It helps us to map Java objects to databases, and it helps programmer because you don't need to worry about how to query something from the database. Hibernate takes care, once you do the mapping, Hibernate takes care of updating, deleting, inserting something in. Everything Hibernate takes care of. It provides simple syntax on how to do it. So now actually I should say JPA takes care of it. So once you follow the JPA specifications and do the proper mapping, then Hibernate helps you to implement that particular stuff. So how does Hibernate really work? Hibernate, like if you look at Hibernate, you have the application and you have the database, and really the Hibernate fits in between all of them. So Hibernate is the layer between your transient, your objects which are going to be stored to the database, that's the persistent objects, and the database themselves. So Hibernate kinds of defines the mapping between the persistent objects and the database. We create a lot of mapping files between the persistent object and the database, and Session Factory is just a cache of it. I mean, all the mapping files are loaded and they are available in the Session Factory's cache. Session is basically something which kinds of represents a conversation between the application and the database. Let's say user clicks something, update a particular user. I mean, user clicks update account on the screen. So you need to take the account details and you need to update it to the database. So the details first come from the screen to the persistent objects. Once they come to the persistent object, a session is created, a Hibernate session is created, and during the Hibernate session, the persistent objects map, the appropriate queries are run to update the database with those particular things. Here, the session is needed so that whatever values are there in the persistent objects are transferred to the database. The most important thing is this session is per request, or something of that kind. The next important thing is Hibernate also allows you to have transactions. So JTA, Java Transaction API, Hibernate supports that. So basically, transactions are very important because let's say there's a failure in between. Let's say there are 5 steps in doing something and the third step failed. We want the first 2 steps which were done to be cancelled. Otherwise, the system would be in a inconsistent state. So that's where the transaction management comes into picture, and Hibernate really has a good support for transaction management as well. In your screen right now is really a small entity called called person, which is mapped to another table called table person. So here we are taking a class called person and we are mapping it to a table called table person. We are also saying there's a unique constraint. The unique constraint is person ID. I mean, the ID should be unique. So we are defining the unique constraint as well on it. We are saying this thing maps to a column named name, and this particular ID maps to a column named ID. So this is basically the way you define the mapping between a class. The class here is person. I mean, that's basically, when we looked at the picture, the person is a persistent object. That's the object we want to store to the database, and a table is part of the database. So we are mapping a persistent object with the table inside the database, and we are defining the mapping to it. So that's basically a sample example of how you can map an entity to some database in Hibernate. In Hibernate, there is a @immutable annotation. This @immutable annotation is helpful if you define it on the table. If I define it here, then it means this table content will not be updated. I mean, the content of this particular object will not be updated. So you don't need to really take this content and store it in the database. It would be only some kind of read-only data. It will never be updated. It helps Hibernate kind of do a certain amount of performance improvements. So the next important thing is, how do you define unique identifiers? Most important thing in a relational table is how do you uniquely identify a row in the table, and when you insert a new row into a table, how do you really generate a unique identifier? That's one of the quite tricky questions when it comes to databases. A lot of times we use sequences. I mean, in databases, in old times with Oracle, I was creating hundreds of sequences, a sequence for every table which is there, and we use the sequence to generate the ID. With Hibernate also, we have support for sequence. You can use a sequence as well. I mean, you can say, I want to use a sequence from the database. So I can say, I want to use the strategy of generating from a sequence, and the name of the sequence is this. So that's an option. The other options are something called an identity. This is only supported in these particular databases. The one option is for you to write your own logic. I mean, you can define a custom generator, which kinds of, you want to talk to a database, you can talk to it and get and generate an ID. You can write a lot of logic there, or you can put it to auto. Then Hibernate decides what is the best way to generate the ID, and it would give it to you. So these are the different ways which are possible to generate an identifier in Hibernate. What is optimistic locking? It's a very, very, very important question. I mean, especially when you talk about transaction management, if there are a lot of parallel transactions running, you don't want to hold a lock for a long time. If you hold a lock for a long time, then the other tables cannot access, I mean, other queries cannot access the table, other transactions cannot access this table, and it would mean that the application would slow down a lot. So how do you improve the performance of the application? That's where the optimistic locking comes into picture. So optimistic locking is like, you don't really hold a lock to the table. You just have a cache of what was the old value. And when you're trying to update the column, you check whether the old value is same as the current value. If the old value is not really the same as the value in the database, then it means somebody else has updated the value in the meanwhile. Then it means there's an error. So I mean, that is something which needs to be handled. But what what optimistic locking allows is that there would not be a lock on the table. So all the other transactions can go ahead and access the data from this particular table, and the performance of the application will be better. So Hibernate actually provides two approaches to optimistic locking. Either I can use a version number or a timestamp. So you can using the version number is really the best approach for using best approach to use with Hibernate. You can use the @version annotation. So you're defining, this is the column. I mean, this is the column which is very important. Whenever something gets updated in here, this column also gets updated. So you just check whether this particular value is the same as what it was when I read this particular row. If it's the same, then it means that the row has not changed. If it's different, then it means that some update has happened in the intermediate stage, and so whatever data I'm trying to update will lead to an inconsistent update. So that's basically optimistic locking, and that's how you do it in Hibernate. The next important thing is mapping a hierarchy of classes to Hibernate. Let's say there are, let's take this example. There's car, and the Formula1 car extends car. So you have two classes. One is car, and the other one is Formula1 car, which extends car. So there are multiple ways how I can map this kind of a structure to a database. I mean, in the database, I can have two different tables for each one of these, or I can store these values in the same table. So the first strategy which we are going to discuss is how we can store both these classes. I mean, how we can map both these classes to the same database table. So that's the first thing that we would discuss. So that's where we use the strategy called inheritance type called single table. This is called single table per class hierarchy. So this is called single table per class hierarchy. So there's a hierarchy of classes car, Formula1 car, and I'm using only single table to represent these two classes in the database. So how do you define that? Is by using a strategy called inheritance type dot single table. That's what you say, and then you would create a discriminatory column. So you would say discriminatory column is the car type. So the car type, what would be the value? Would be the discriminator type is string. So the value for this car type, I mean the type of this car is string, and here you are defining when I'm creating on the car, I'm putting the value for the discriminator car. It's car. This is Formula 1. So what happens is when I try to store car to the database, then the field car type will have a value of car. If I try and store Formula 1 car to the database, then the field in the database car type would have a value of Formula 1. This is how you can map a single table per class hierarchy. So this is how you class a hierarchy of classes to the same table in Hibernate. The next important, the other way of implementing the same thing is to use table per class. So you decide that I would not want to have the data related to these two things. I would want car to be in a separate table and Formula 1 car to be in a separate table. Then it's kind of the default. I mean, this is how we map things, right? I mean, even if there's no inheritance hierarchy, I can really map these two things to two different tables. So, I mean, here I'm putting a annotation saying inheritance table per class, but it's not really needed because that's basically the default. So, next question is how to map a one-to-many unidirectional relationship. So I want to create a one-to-many unidirectional. Unidirectional is one direction only. So you want a relationship between the parent to the child, but you don't need a link back from the child to the parent. That's basically a unidirectional relationship. So one-to-many is kind of a parent-child relationship. There's one parent and there can be multiple children. So, not really. I mean, it's maybe like a parent object and a child object. So you can have multiple childs for the single parent object. Let's think that way. So this parent can have multiple childs. So the way you say that is by specifying an annotation called one-to-many. So here I'm saying at one-to-many and I'm defining a set of this child object. So this actually represents one-to-many unidirectional relationship. It's a unidirectional relationship because I don't specify anything in the child. Child doesn't really know anything about the parent. It doesn't have any field which relates to the parent. And if I have a connection back to the parent, so here I'm saying a child, there's a many-to-one relationship to a parent. And this is called a bidirectional relationship. I not only have a relationship from the parent to child, but also there is a relationship between the child to the parent. So there is a link back from the child to the parent. That's at many-to-one. This is how you define a one-to-many bidirectional relationship with Hibernate. Actually, this is exactly how you would even define all of these with JPA as well. So whatever annotations which we are looking at are the JPA annotations as well. So it doesn't really make a difference whether you're using it's always preferred to use a JPA annotation over a Hibernate annotation, because with a JPA annotation you can switch to other ORM frameworks as we discussed earlier. The next important question is how do you implement pagination with Hibernate? The pagination you can implement with Hibernate by setting something called max results on the queries. You can say I want to get only 10 results back. I want to get only 100 results back. I want to get only 1000 results back. So then the Hibernate would return only those number of queries back. And also you can set the first result. So you can say from this particular result, from 500th row I need 1000 rows, or from 50th row I need 20 rows. So you can say first result 50 and I can set max results 20. So that's how you return a set of like when I query something, usually it returns all the results of that particular query. If I want to limit the number of results, you can use pagination. Lazy association. What is lazy association? In Hibernate, the classes are directly mapped to each other. For example, a parent is directly mapped to a child. So whenever I load the parent, if I start loading the child as well, then there is a performance impact. It might be necessary, it might not be necessary to have that performance impact. So in cases where you don't really want to load all the children when a parent is loaded, you kind of make the association lazy. So you do, this is kind of the default configuration in Hibernate. So when you load the parent, all the many to one, one to many associations will not be loaded. They will be lazily loaded, in the sense when they are called they would be loaded, but by default they would not be loaded. This is called lazy association. Next, we would talk about one important performance problem in Hibernate, that's called the n+1 selects problem. The thing is, let's say there is a parent and there are 10 child rows. So there is one parent row and there are 10 child rows. By default, if you leave the configuration as default, Hibernate would use 11 queries, one for the parent and 10 for each of the children to get all the data. And this is highly inefficient. So it's preferred not to use select and use something called join. So this join would prevent this n+1 selects problem. It would make sure that all the children are returned in one query. All the data related to all the children is fetched in a single query rather than using 10 different queries to retrieve details of each child. So that's, the two things, lazy association and n+1 selects problem, are kind of most typical problems that you face with performance related to Hibernate. So you should be very cautious with performance when you are talking about ORM framework, because in the background you should understand what's happening with the ORM framework in the background. What's Hibernate doing in the background? What's the specification of JPA saying? You should understand that and make use of the appropriate mapping to make sure that the appropriate things are really happening on the back end. If when I started with Hibernate, it was a great deal of learning to understand how the mappings work, what Hibernate does in the back end. A lot of things would not be really clear, especially when you are new to Hibernate and you see how easy it is to map. You start doing a lot of things and later there's a performance impact of it, and then you go and look at the back end and you see you have done something really silly. So that's quite common, but you should be really cautious when you use JPM mapping and make sure that there is not really any lot of performance impact because of using a JPA. Next, we will look at a schema generation. So basically, once I map a Java object to a table in the HBMs or directly using annotations in the class itself, I can use that information to generate the entire schema of the database. The tool which helps us to do that is called schema export. The schema export has a lot of features. It can just look at the bean definitions, the annotations which are there in there, and it can generate the entire database table structure with relationships in there as well. And also there is an additional feature where it can generate incremental updates as well. So it's a really useful tool. Also, there are tools available to the reverse. You can give a schema and the tool can generate the Hibernate mappings for you. So it can create the entire beans with mappings defined in HBM, or if you want, even annotations defined in the bean class itself. That kind of things are possible. But be really cautious, as we talked about earlier. Performance, the default mappings sometimes are not really performance efficient. They are not really efficient. So you need to understand them. Even though you are generating them, just take a look at them and make sure that you are making the right choices regarding the mappings. So the next thing is schema validator. Schema validator tool is really a very important thing. A lot of times there's a mismatch between what you define in the Hibernate mapping and what's really in the database. So if I define a specific table name in the Hibernate mapping, but that table doesn't exist, that's basically not matching. The structure of the database doesn't match the mapping. Let's say there is a missing column, or the column name there is a typo. All these are situations where there is out of sync. Where the database and the mapping is out of sync. So schema validator helps us to find these kind of things. So schema validator is a very useful tool for this kind of stuff. Next, we would look at some of the Hibernate best practices. What are the Hibernate best practices? The first thing is have a natural key. I mean, identify a proper identifier. Avoid using a sequence generator to create an identifier. As much as possible, try and use natural keys. I mean, SSN, for example, is a natural key. So use natural keys as much as possible. The second one is, if you're using HBMs, then put each class's mapping in a separate HBM file. Don't have a single large HBM file with mapping for 50 tables. Imagine 10 developers working on that particular file. It would be a mess. So make sure that you use each class mapping in its own file. Also, using queries with Hibernate is not really recommended, but in certain situations where performance is really critical, you would go for queries. And when you go for queries, try and externalize these queries. So try and put these queries in a property file or in an XML so that they can easily be changed at a later point in time. This makes the applications more portable. Also, all the time when you go for SQL, use bind variables. Never use direct SQL queries, because it's kind of a security flaw. I mean, if you directly use string concatenation to generate SQL queries, then there's a chance that SQL injection can happen. So to avoid it, always use bind variables. Never concatenate and generate the queries. As I said earlier, try and use hand-coded JDBC as much as possible. I mean, using SQL completely defeats the purpose of using Hibernate. So unless there's a performance critical requirement, don't use hand-coded SQL. And also, I mean, this is kind of the default. Use always lazy association for lazy fetching for associations. So that's really the default. So also, make sure that you're only using lazy fetching, and you would disable the eager fetching in a lot of places. And always use bidirectional relationships. Have the relationship from the parent to the child and child to the parent, so that it's easy whenever you have a child to get to the parent, or whenever you are at the parent to get to the child. And the last one I would want to leave you is, try and understand the n+1 selects problem and try and avoid it all the time. So n+1 selects problem is kind of the most common performance problem with Hibernate. Try and avoid it, understand it, probably do an example and try and understand it, and try and avoid it as much as possible. So there you go. Those are all that I would want to talk about regarding Hibernate. These are all, we looked at a varied range of aspects regarding Hibernate. We started with how to map a single file. I mean, we started with what is JPA, how Hibernate is related to JPA, and then we saw how to map an entity, how to map a hierarchy of classes to tables. Then we looked at different tools which Hibernate offers, schema validator, schema generator, and all that kind of stuff. And we ended up discussing the Hibernate best practices. So there you go. That's all I have to share, and have a nice day.